Now, I really would expect my channel to be a subset, my channel's viewers to be a subset of Big Clive's, but I'll post up a card with his channel. You should definitely subscribe to Big Clive in case you aren't. But yeah, basically what I've observed and what he actually went over on his channel and what I'll basically copy on this channel with a bunch of, I'm not sure he did this one, but basically anyone finding these has to pick them up because they contain 400, in this case, 400 milliamp hour cells. And this big one, I have no idea how beefy this is, but we'll check it out. And just to make this video a tiny bit different from his, I will actually time-lapse a discharge and probably just a charge cycle with my power monitor, just to see exactly the capacity of these cells after, what, like half a use, because they still come up at around 3 volts, 3.2 even. Right, so to open these, it's not really a big deal. The mouthpiece usually comes out pretty easy, and then this end bit also doesn't put up much of a fight. Let's see. All right. So there's this pressure sensing microphone slash MOSFET slash LED assembly. These are very nice. I have no idea what I could use these for, but yeah. Basically detect a vacuum in here and activate the burner, right? The, what is it called? The heater, sorry. Boy, it's a fat boy. What does it say? 600, 900, Jesus fucking Christ. Oh my God. All right, yeah, not too bad. Let's see if we can trigger this. Does sound pretty nice. So all you have to do is trick this into thinking there's a vacuum, so. Oh yeah. Yeah, it smells pretty nice. All right. So disconnect this. And yeah. All right, so this cell is basically almost as much as what a DualShock 4 controller has inside of it. And they go pretty much the same way. End cap comes off. End cap has little gap here to let air through. And same as before, just rotate this. Oh, and by the way, this is a metal disc, metal tube. So no, I just like to keep these. I have no idea what I could use these for, but they're pretty nice, I don't know, metal tubes. I don't know. Okay, I think maybe we can pop these out this way as well. Yeah, maybe not. All right. Same as before, metal tube. No idea what I could do with these, but at least I have them. All right, same as before, you can trick these into actually pumping power into the resistor. So just suck lightly on this shit. Yeah, this was super dead. All right. And I don't know. It's pretty hard to salvage from this particular model. Yeah, so they have this tiny LED and just 3 wires. If anyone has any idea what I could do with these, definitely let me know, because I am accruing quite a few by now. silicon piece for a disposable item. Like, damn. This is very wasteful. And this cell is 550. Let's see. This one's also dead. All right, so it doesn't want to play anymore. Okay, this cell is... Doesn't say. Interesting. So they're just sourcing whatever they can get, right? So not exactly the same deal, but... and these are the same brand, right? All of them. These three ones. Right, so what is this called even? Elf bar. Are they different? I'm not sure. I have no idea. Anyhow. Fact. Okay. All right, so again, this has a third construction. Oh my god. All right, so these are actually different. But why are the two elf bars different? Pretty weird. Anyway, so this is the more expensive silicon-y type. Isn't silicon like super expensive? Yeah. All right, let's see if this one still has life in it. All right, this one does have life in it. Let's get it to burn a bit. All right. Anyway. Okay, and this is again 550. So yeah, very nice. So next up, I'll test the capacity of these. We'll get a little time-lapse action going, and hopefully my voice will be better when I come back to this, because right now it is a struggle. All right, so my past self has directed me to measure each cell's voltage, and then the next part is going to take quite a while, so I'm going to do a time-lapse discharging these through a DW01. So that's a lithium-ion protection chip. Just going to put a little snippet of the data sheet on the right side. And so basically what that'll do is it will cut the discharge at about 2.8 or 3 volts or 2.7. I don't know, something about around that. I don't know. We'll see. And that is going to give us a rough estimate of how much capacity these have left, and we can then benchmark this with the full capacity that we're going to be able to pump into them. So first off, the voltages. All right, so let's check the fat one first. 3.3. All right. Okay, so this one actually is quite discharged. Yeah, super chill. Okay, so let's head on over to someplace else because I do want to sleep here. And set up the time lapse to get these discharged. All right, so next up, past Arya says that we should build the batteries into fairy lights. And so I'll probably either be going with one or two of these. These are pretty similar. They clocked in at 550 and 555. Yes, pretty equal. The lights we'll be using are these. So these are some Strala lights from IKEA. You guys can check the code. Although this is not the code. Anyway, pretty recognizable. It's more of a thick wire compared to what you see out of AliExpress. Same thing, they just solder some SMD LEDs. These are quite cold, to be honest. I don't like them too much. And then pot the whole thing in some kind of a resin. I don't know, this looks pretty hard and very nice. Construction is very good. And they have this 6-hour on mode. Oh, by the way, this is how they look. So they always will turn off for like 18 hours, which is very good. But still, these will chew through a lot of batteries and are fucking up my planet. So not good enough. Right, so we're going to be swapping in 2 AA's. For either 1 or 2, again, I've not yet decided. And since these are 4.2 volts down to about, like, let's say 3, they are above the voltage that these come in at, right? I have cooked up a theory of operation, going over what I want to do and also a few of the currents, right? So if we leave these at, directly connect them, they should still work. There's a lot of LEDs, right? In parallel. I think it's 30. I roughly counted. I don't know. Plus minus 5. It's definitely right. The voltage is definitely going to drop. So it's not going to be 4.2. It's not going to be 3.5 hours, even if we let them directly, right? At 3.7, they're drawing 90 milliamps, which would be roughly 5.5 hours, right? Assuming I use just one of these cells. 3 volts, 35 milliamps, 14 hours, and 2.5 is 20 milliamps, so 25 hours. And if this clocks, goes in and out, then that's going to be, like 4 days? 4 days worth. So, yeah, I don't know. Decent. But then again, do you really want to charge this every 4 days? Yeah, maybe I go with 2. I'll probably go with 2, right? There's a little star here because I'll be using this buck converter. What the fuck happened here? Anyway. So these are very nice. This is the chip. And this says it goes up to 24 volts, but it actually supports, tolerates 30 volts in my tests without overheating, without anything. These are very, very efficient. And you can program them down to 2.5. The only single downside this has is that it will cut at 3.4 volts. Fortunately, right, the discharge curve of a lithium-ion battery is kind of plummets after 3.5, so to say, right? And it plummets even more after that, right? So you can indeed use them below 3 volts, but there will be very little energy left. So the integral of this function, right, the area under the curve, gives you the actual energy that is inside the battery, right? So if you stop discharging at 3.7, you'd get half, sort of, right? So like this, we should be getting like a lot. Should be fine. And yeah, so I want to have either 1 or 2 cells connected to this tiny buck. Just go down to the cells, to the string, sorry. And for the charging, I'm going to be using a TC4056. These are very nice. And now come in with Type-C. The only issue with these is they still don't seem to have the resistor that tricks smart um, smart Type-C chargers to actually give power. So you can only use them with dumb Type-A to Type-C cables, such as this one. Yeah, a bit of a limitation, but piss with the cock you've got. I don't know. Could try soldering in a resistor there, but yeah, I don't know. Or maybe I could over here. I don't know. We'll see. We'll see. But yeah, apart from that, that's pretty much it. So next, I think I'll just go with the time lapse or like fast forward of me actually building this. And we'll talk again once it's done. Yeah, see, they don't really. Stick these in this way. Okay. Let's see. Jesus. Beautiful. Either just the regular metal cutting disc or the diamond cutting disc for even more precision. And so I'm gonna go with this one. This one is insanely beat up, but well, still seems to work and has the nice shiny diamonds. All right. Yeah, so this should fit perfectly now. Let's see. Perfection. Not perfection, but anyway, so I'll probably... Yeah, you know what? Good enough. Okay, and as far as the buck module is concerned, this has a few options. One of them is to set this trimmer. However, I highly recommend you make away with this, do away with this, because it is a piece of shit. These do drift, unfortunately, pretty badly, and will ruin your day eventually. So you could either cut the trace here, or just snip it off, which is what I do. This may seem a bit barbaric, but it is what it is. And then next up, we'll bridge the 2.5 volt connection. Yeah, looks fine. Okay, so one of the last steps will be to shrink this in shrink wrap. You might have seen me doing this before with the clear one, but I actually did forget to connect the negative. I did actually connect this last so that nothing would be live until we're almost done, and now it does work, right? So great success, but still a few odds and ends to tie up. And now this can sit over here, and let's see if there's enough room for the batteries, and there should be just barely enough room. And there is, very nice. Okay, and last but not least, I do want to fix this into place a tiny bit better, and for that I have Mammoth. I don't know if this is available in other countries, but it's pretty good. It dries very elastically, but like very elastically, and it clings onto shit extremely tightly. Hoping this is not clogged, but anyway, let's see. And so this does indeed seem to be clogged. We'll just cut a bit off. Some thick scratches should do. Random directions. Let's quickly see if they charge, and then we'll be done. Yeah, not bad. Let's turn off the lights, see how these look. Yeah, should be fine. Let's get the kind of light output we're getting. Could probably check the current, but too late by now. And yeah, do let me know if you guys find any other uses for these. But other than that, have a good one. So just for posterity, this is how it looks. Brightness is, I would say, ample for ambient illumination. You can definitely see in this room with this being on alone. And the runtime is pretty impressive. I did get 60 hours out of it, so not a bad result. We're expecting the lithium ion to go down to 80% capacity pretty quickly, but I don't know. Should be fine.